Understanding the O.S.I and TCP IP model. The O.S.I Open Systems Interconnection Model is a conceptual framework used to understand network interactions in 7 distinct layers. Each layer has a specific role, ensuring smooth data transfer and communication over a network. 1. Physical layer. The network's foundation builder function handles the physical components like cables, coaxial, fiber optic, switches, and hubs. It's focused on transmitting raw data bits across these hardware elements. Protocols includes Ethernet for wired setups and 802.11 for wireless. Analogy: think of it as the muscles and bones of the network, dealing with tangible aspects like voltage levels and physical connections. 2. Data link layer. The local network organizer function acts as a bridge between hardware and network functions. It organizes data into frames and manages error detection, correction, and data addressing using MAC addresses. Protocols: Ethernet, PPP, and ARP are key here. Analogy: a meticulous organizer ensuring data is neatly packaged and accurately delivered within the local network. 3. Network layer. The global data navigator function functions as the network's GPS, determining the best routes for data packets using IP addresses. It guides data across various networks. Protocols: IP, ICMP, OSPF, and BGP are essential tools. Analogy: responsible for smartly forwarding data packets along the most efficient paths. 4. Transport layer. The quality assurance expert function ensures complete and reliable communication across the network, manages data flow, focusing on reliability and speed. Protocols: T.C.P for reliability and UDP for speed. Ports like HTTP 80, HTTPS 443, and FTP 2021 are significant. Analogy: oversee that the right data reaches the right application, maintaining quality in data transfer. 5. Session layer. The network's conversation facilitator function manages communication sessions between applications, much like a moderator in a discussion. Protocols: NetBIOS and PPTP, focusing on establishing and maintaining connections. Analogy: ensures smooth dialogue flow, controlling the timing and duration of interactions. 6. Presentation layer. The universal data translator function converts data into various formats, handling encryption and decryption for secure communication. Protocols: SSL and TLS, focusing on data representation and security. Analogy: the Rosetta Stone of the network, ensuring data is in the right format and secure. 7. Application layer. The user's digital interface function. The interface where users and network services interact. It's the front end of networking. Protocols: HTTP, FTP, and DNS, with significant ports like 80 HTTP and 443 HTTPS. Analogy: handles user-facing services like web browsing and email, providing the interface for network interaction. Exploring the TCP IP model, the TCP IP. And then there's understand how different network protocols interact in the Internet Protocol Suite. It consists of 4 layers, each with a specific role in handling network communications. 1 link layer, the network's foundation function. This layer is responsible for the physical transmission of data over the network. It includes elements like Ethernet cables, switches, and network interface cards (NICs), protocols and components, Ethernet, Wi-Fi, and other physical network technologies. Analogy: think of it as the physical infrastructure or the road upon which all network traffic travels. 2 Internet layer, the global data router function. This layer handles the routing of data packets across networks. It determines the path data takes from the source to the destination using IP addresses. Protocols. IP, Internet Protocol, is the key player here, along with ICMP and ARP. Analogy: acts like a global positioning system (GPS) for network traffic, guiding data packets to their destinations. 3 Transport layer, the Reliable Delivery Manager function, ensures that data is transferred reliably and in the correct sequence. It's responsible for error checking and flow control. Protocols. TCP Transmission Control Protocol for reliable communication, and UDP User Datagram Protocol for faster, connectionless communication. Analogy: comparable to a postal service that ensures your letters' data packets are delivered accurately and in order. 4 Application layer, the User Interaction Facilitator function. This is where users interact with network services. It encompasses protocols that provide specific functionalities like web, browsing, email, and file transfers. Protocols: HTTP, HTTPS, FTP, DNS, and SMTP are some of the key protocols in this layer. Analogy: think of it as the user interface of the Internet, where users access and use various network services and applications. Each layer in the TCP IP model plays a vital role in the smooth operation of Internet communications, ensuring data is transmitted efficiently and reliably across networks. While the TCP IP model is broadly used in real-world applications, particularly in the Internet, it's less granular than the O.S.I model, but provides a practical framework for understanding network communication. Comparison and practical usage. While both models aim to clarify network operations and assist in troubleshooting and designing networks, they are used differently in the field. The O.S.I model, with its detailed layering, is often used as a reference tool to understand network functions and design principles. Its comprehensive approach is beneficial for education, troubleshooting, and understanding the full scope of network operations. TCP IP model, on the other hand, is more practical and aligned with the protocols used in the Internet today. It's widely adopted in real-world networking and is essential for understanding the Internet's operational framework. Importance in network design and troubleshooting. Understanding both models is crucial for network engineers. They provide a structured approach to diagnosing and resolving network issues and a language for describing network functioning in a layered manner. For troubleshooting, network professionals can identify at which layer a problem is occurring, allowing for targeted interventions. In network design, these models help in segmenting and organizing network architecture, ensuring each layer's protocols and components are optimized for efficiency, reliability, and security. In summary, while the O.S.I model offers a theoretical and comprehensive approach, the T.C.P. IP model provides a practical framework aligned with the current Internet standard. Both are invaluable in the field of network engineering for efficient network design, management, and problem resolution. Understanding how data flows through these layers and the role of each ensures robust, efficient, and secure network operations. CompTIA Network Engineer Training. Both the O.S.I and T.C.P. IP model can be likened to the postal system in terms of how they organize and manage data transfer across networks. Here's how the layers of each model relate to the various aspects of the postal system. O.S.I model similarities with postal system. Physical layer O.S.I postal transportation. This is akin to the physical means of transporting letters and parcels, such as trucks, planes, and delivery personnel. It represents the physical infrastructure used to transmit raw data bits. Data link layer O.S.I, packaging and addressing, similar to packaging a letter and labeling it with a recipient's address. The data link layer takes care of framing data and providing physical addresses, MAC addresses to the frames for delivery on the same local network. Network layer routing. This layer functions as the postal sorting facility, where letters are sorted and directed towards their final destination. The network layer determines the best logical path for data to travel across different networks. Transport layer delivery assurance, comparable to registered mail services, ensuring the letter reaches the correct recipient and in the right order. The transport layer manages the reliability, flow control, and error checking of data packets. Session layer organization of conversations. This is like managing a series of correspondence between two parties, ensuring that the conversation is organized and coherent. The session layer establishes, manages, and terminates the connections. Presentation layer letter translation and encryption. Just as a letter might be translated from one language to another or sealed for privacy, the presentation layer handles data translation, encryption, and decryption. Application layer postal services. This layer represents the postal services offered, such as mail sending and receiving. The application layer provides network services directly to the users. T.C.P. IP model similarities with postal system. Link layer postal transportation. This layer is analogous to the combination of physical transportation and initial handling of mail, similar to the O.S.I's physical and part of the data link layer. Internet layer routing, like the sorting and routing of mail based on destination addresses. The internet layer routes data packets across multiple networks using IP addresses. Transport layer delivery assurance, ensuring that messages are delivered reliably and in sequence. The transport layer is much like ensuring that mail is delivered accurately and intact. Application layer postal services. This layer is where users interact with network services akin to utilizing various postal services like sending letters, parcels, or registered mail. Similarities in functionality. Layered approach. Both models use a layered approach to manage and facilitate data communication, much like how the postal system uses a structured process to handle mail from sender to receiver. Encapsulation and decapsulation. Just as a letter is wrapped encapsulated and unwrapped decapsulated as it moves from sender to recipient, data packets are similarly encapsulated and decapsulated as they travel through the layers. Addressing and routing. Both models employ specific addressing schemes and routing protocols to direct data to its destination, akin to how the postal system uses addresses and sorting to ensure mail delivery. By understanding these similarities, network engineers can better grasp the complexities of data transmission and the structured process of communication within networks, leading to more effective design, troubleshooting, and management of network systems. Each layer's role and operation in the O.S.I and TCP IP model contribute to the overall efficiency and reliability of data transfer, much like the various components of the postal system work together to ensure the accurate and timely delivery of mail.